All right, so quiz preview, quiz 2. Again, when you see words here on number 1, like identify the transformations, remember, that is just a fancy mathematical way of saying shifts. Will I use the word transformations tomorrow? Will I use the word shift? Probably not. So, basically all this is asking you is, what directions are those two shifts? But I need to put the numbers with them. So again, inside the parentheses, left, right shift, opposite of what I would think. So we're going to go left 1. Outside is my up and down shift, which again goes along with what we think it would be. So that one's going to be down 7. That's all we need there. But again, you've got to put the direction and the number so I know which one you're talking about for each. The second part, rewrite the following in either logarithmic or exponential. Now, that's assuming here that if it's in log, we're going to go to exponent. And if it's in exponent, we're going to go to log. So, I usually will start with the log to exponent, because that's usually the easier one to do. Because again, that little tiny number is always going to be my base. The number on the other side of equals is always going to be my exponent. And then this is always going to be my solution. Now here's the part where I maybe wasn't quite as nice. There's no real way to check it this time because of where I placed the x value and not just making it a number. I want you to know that you know your form. So again, base, exponent, answer. Once you get this one, the nice part about that is now when I come over to number 3, I have an example to work with. So I can kind of look and go, okay, so I know this is going to be a log 1. Okay, so what's the little number? The little number is this big number here, this base value. Okay, so the little number here is going to be 8. So there was 5, here it's 8, okay. So then the exponent was the answer, okay. The exponent was the answer. There's no other place to put y. Okay, let's see if these look alike. Base, exponent, answer, base, exponent, answer. Yeah, that's how this is going to work. So, and this one I could see 8 to the 5th equals y. Practice. If you haven't, there's lots of chances with the worksheet yesterday that we did, and within that original assignment we did on this to play with these. You've got to play with them. If you haven't, that's going to be rough. Okay. Evaluate. Change of base. This is all calculator all the time. And again, if it's been a while since you've done a change of base, it's the log of our of value, the number on the right, divided by the log of my base value. Sometimes you may get negatives, sometimes you may get decimals or fractions, sometimes you may get whole numbers. That's not the part we've got to really concern ourselves with. You're like, what? You get 0. Okay, so as you're going through these, trust yourself. Or if you get one like that where you're like, I'm not sure about that one being the right answer, you know, kind of go to the next one and try it again and see if you can find one that you're a little more confident in with your answer. But if you start to get decimals all the way across, think again, maybe you're switching the values around. You've got to make sure on these. Most of them will probably be whole numbers. I can't guarantee every single one, but a good chunk of them probably will be. So let me try and stay out of the glare here. And really the only way you can mess these up, and I've mentioned this before, is if you forget to close your parentheses on the first one. Otherwise, it's not too tough to get your values. Okay, so log of the number on the right, divided by the log of your base, that little itty bitty number down there at the bottom. So that should be some easy points for us. Find the inverse. Okay, let's remind ourselves of the steps. There's two. We're going to switch x and y. And then we're going to solve for y. It's only those two steps every time on these. These problems really do go quickly once I just know what it is I'm trying to do. So for this one, okay, I switch my x and y. Okay, that's not the bad part. Now I have to think about this for a minute. My job, excuse me, is to get y by itself. Well, how do I do that? I need to get the log 10 out of there, but I can't just divide it out. That's not how an opposite of a log works. So let's introduce the first of our log inverses again that we talked about. You can take a number and the log of that number, and they'll be inverses of each other. But what we're going to end up doing here, and we busted out this big word before, is we're going to exponentiate with the base word in there being exponent. Whatever this little log number is, and if I didn't happen to see a number there, we assume it's 10. I'm going to go to both sides of my equation because the 10 and the log 10 are inverses. They would cancel out with each other, leaving me with my y. And then this side, again, exponentiate means it's 10 to the x power. Not 10 times x, that's different. If you write 10 times x, it's not right. But 10 to the x power, because that's how we get rid of that log by, again, that big word exponentiate. So basically, switch x and y one step, I'm done. So let's see here, what else we got? Okay, expand. Again, between your notes from when we did this originally, and then what we've got on the sideboard right now, you have that process down in your head. So when we go to expand, normally what I look for first is I'm going to turn division into subtraction. What if I don't have any division? Why did I skip that step? So if I get to skip that step, the next step is to turn multiply into add. Well, I got lots of that. Because here, between the 7 and the a and the m squared, I have multiplication dots. So, I'm going to have log of 7. Wherever the multiplication dot would be, I'd put a plus. The log of a, and again, between the a and the m squared, plus the log of m squared. So every multiplication dot becomes a plus sign. And then my final thing to look for, if I have them, is to turn my exponent into a coefficient. So if I see any of my terms have an exponent, we swing that back to the start of that particular term. So all the other stuff stays the same. And once I've done that last step, I'm done. So that's it's kind of an additional bonus of knowing those 3 steps. Once you get to the last one and done it, you know you've done everything at that point. And it's not like you can take it and do any more with it. And I'm done with that one. Okay? Now when I get to 10, I'm going to get to do a little of everything this time. So this will be good for us. So I get to 10 and I go, okay, if there's divide, there is. That becomes subtract. So, I've got log ab to the 5th minus, because that's where the division is, log of x to the 4th. So I've taken care of the division. turn it into a minus. Once that's done, now I go looking. Do I have any multiplying? I do. This a times b to the 5th right here. So, I'm going to take this guy, and that's going to be log of a. Here's where my little multiplication dot would be. Plus log b to the 5th. And then I leave that last part alone. So divide became subtract. Multiply became add. And now my last job is to find those exponents and swing those guys back to the front of their term. Not all the way to the start. But just so I don't have any exponents anymore, and since that is always my last step, that's as far as I'm going to be able to go. But again, just keep reminding yourself, it's like exponent rules, except for the exponent coefficient thing. Okay? Otherwise, they're the same. Now, when we go to condense, though, it's like we're doing everything backwards. We tried to go from one log here into all these multiple logs, and now we're doing the opposite. So, since I kind of hosed myself over here on room, move this up a little. I'm going to do a little sidebar with our condensed steps here. So when we're doing condensed, we basically go back up the chart. So 1, I do coefficient to exponent. So if I have a number in front of my log or natural log, they work the same way. My first job is to get that turned back into an exponent. So like on number 11, that 5, and again, don't take the negative with, just the number. So I end up with b to the 5th. Then I look. If I have any addition, it goes back to multiplication. Well, I don't have any addition, so I get to skip that one on this one. And then finally, subtraction is going to turn back into division. So it basically is going exactly backwards from the expand stuff. So even if you just remembered one of these, and just remember they go backwards. So we're going to get down to one single log. A minus becomes divide b to the 5th. One log. I am condensed. And it'll work that same way on number 12 as well. Except this time again, I got a little more work to do at the start. So I look, I'm like, okay, coefficient to exponent. I got lots of coefficients this time. Every one of my terms has one. So I get log of x to the 4th plus log of y squared minus log of w to the 5th. Coefficients to exponents. Then, if I have any addition, and I do, that's going to go back to being multiplication. So, log of x to the 4th times y squared, and becomes multiply, minus the log of w to the 5th. And again, I'm a proponent of doing it one step at a time. You can try to do multiple steps, but a lot of times that just gets people confused and messed up. And then finally, minus becomes divide. And we're going to get to one logarithm. So I take my x4th times y squared, put it over my w to the 5th, and I'm done. So again, you've had lots of practice there It's just, have you done the practice? And if not, you've got some more to work on, or maybe do some of the problems that we hadn't done before. Oh, now the review starts. When looking at the function f of x equals 3 times 5 over 4 to the negative x, is it growth or decay? Justify your answer. And justify your answer doesn't mean the graph goes up or down to the right or left. So here's my first question. What's my b value on number 13? Okay, the 5 over 4 is. So now, 5 over 4. Okay, let's pull this up for a second. 5 divided by 4 is 1.25. So normally, if you have a b value that's greater than 1, is that growth or decay? Okay, so that is normally growth. But what does the negative exponent do? Right, okay? But negative x flips it to 4 over 5. Whatever's inside gets flipped. 4 over 5 is less than 1. Which is decay. That's your justification. You can't just say, look at the calculator and say, oh, it's a negative exponent. That doesn't tell me. Because if it was this way of start, and I had the negative, now it would become growth. If you want to look at the graph, so you kind of have an idea to make sure you did it right, okay, that's fine. If you wanted to pull this up and go, okay, I want to look at it. But just looking at it and punching it in, and by the graph seeing that it's coming down, that it's decay, okay, that in itself is not the justification. You've got to explain mathematically reciprocal or flips and put some numbers in there to do your explanations. Otherwise, it just doesn't quite work. And then 14's kind of swinging us back up to number 1 type idea. If f of x is f of x is 5 to the x, g of x is 5 to the x plus 4 plus 3, explain how to obtain g of x from f of x. What is the transformation? Again, what are the shifts? Exponent is my left and right, and it's the opposite of what I would normally think. So minus would be right, plus would be left, and this is my up, down. Don't let the word transformation throw you off. Okay, it's just a fancy way of saying shift. Issues on the front. So we're kind of going into our mix mode here of review and new stuff all together here so we don't forget it. All right, to the back we go. Graph the function. Again, I have no issues if when you get a graphing problem, you decide that you are going to just type it in. Not an issue at all. You can even take a peek, kind of see what you're getting into here. Looks pretty decay-y to me. So I pull the chart, and again, we try to use the whole numbers as best we can. And I am going to pay a little bit of attention to if you go crazy here and aren't really paying attention to where your graph goes. For instance, on this one, I notice that it gets down and it levels off at 2, or numbers that are really close to 2. So I shouldn't see your graph coming down here to the x-axis. That wouldn't make sense. So once I graph it, my domain, and here's where we get to be careful, this is going out in both directions forever. So on a growth or decay, my domain is negative infinity to infinity. My range, which normally would be 0 to infinity, unless there's an up or a down shift, which there is. So I can either look at the picture and say, hey, this gets kind of close to 2 and then goes up forever. Or you can just know, hey, it's normally at 0, but it shifted up 2. So now I know the shift tells me that it went up 2. They both work. Okay, that's the cool thing about this. There's lots of ways to get there, and it doesn't have to just be your brain memorization or just a calculator. And then end behavior. Okay, let's chat about reminders of end behavior. These x's go directly with your domain. Well, since the domain's the same every time, so will be the x values in my end behavior. So that shouldn't be hard to deal with. My range numbers go with the f of x's, because f of x is a fancy way of saying y. So one of these is going to be 2 and the other one's going to be infinity. Well, how do I know? What we were doing before was we'd say, okay, as x goes to negative infinity, as x goes to the left, and we'd literally write that on there. As we're going to the left, am I going up forever? Am I getting close to 2? Well, I'm going up forever. So this one gets the infinity. As x goes to the positive infinity, as x goes to the right, I'm getting closer and closer to a y value of 2. These match up. These match up. Okay? Lots of connections to make if you practice. And then the same thing dealing with 16 with my logarithm. Again, I'm going to assume a lot of you are going to go to the calculator, even though you could take your 2 parent points, your 2 base points, and shift them. Because again, this is going to be right 5. So if I went to the calculator, and I'll show you both side by side here. There's my log. So I notice my 2 points when I'm doing my logarithm are at 6, 0, and 15, 1. That's going to be a hoot to try and graph. We'll get back to that problem in a minute. If I move right 5, that's an x value. 1 plus 5 is 6. 10 plus 5 is 15. You can do it without the calculator, but again, you don't have to. Ooh, 15. Okay, we're way out here somewhere. And here's our other thing to watch on the graph. 2 things, actually. 1, my asymptote. I know I didn't ask for 1, but my asymptote's where that first error message comes. So at x equals 5, my asymptote's there. Why is that important? Because when I look at the graph, remember, the calculator doesn't show the whole graph. My graph does not stop here. My graph keeps on going. So if you just copy what's on the screen, you're not going to get it right. You've got to get the whole thing on there. And these guys, so we can kind of see the big picture of things here. And these, my range is the negative infinity to infinity. These switch when I do a log. And it's my domain that is normally 0 to infinity, unless there's a left or a right shift, in which case it goes where my asymptote does, 5 to infinity. If I move left, it'd be negative whatever number to infinity. So then my last piece of this, okay, is my x-intercept. My x-intercept occurs when y equals 0. Now, if I'm fortunate enough that when I scroll through, I see y equals 0. Oh, good. Okay, it was a whole number. I'll just do 6, 0. Okay? But what if it isn't? And that could be a possibility tomorrow. If it isn't, here's what I have to do. I'm going to plug in, I'm going to go to my equation. I'm going to plug in 0 where the y is. And I'm going to do a little bit of algebra. Now, we've said this earlier, but I don't remember. If I have a log with no little number here, what's the little number again? 10. So I'm going to exponentiate with my 10 to get rid of the log. And then 10 to the 0 power, if we don't remember, is 1. One last step to get x by itself. I plus 5, I plus 5, x equals 6. There's where it's coming from. So if you don't see it on your chart, that's the little extra step you've got to do. It's sort of like doing the inverse step is basically what you're doing there, except you have a number in there for it. Okay. Again, we did plenty of those the first couple of days we were doing these too. So practice makes perfect. Go back and use that if you need to. Maybe use this as a guide for you. And then finally, we're going to end up with some apps from growth and decay. So a scientist estimates that a specimen begins with 450 bacteria, grows by 15% every minute. Write the equation that represents bacteria's growth and calculate how many minutes will pass before the population reaches 1,000. Okay, notice every one of these, I'm going to tell you what the formula is or what the format is. So here, A is my starting amount, 450. 1 grows plus. What's 15% as a decimal for my R? 0.15. And then we don't know the time, so I can put t or I can put x there. Okay, that's my equation. When will the population hit 1,000? Okay. Well, now that I've got an equation to work with, again, make sure that you get your parentheses, that you're using plus, that you did 0.15 and not 15. And then basically just pull your chart and start looking down the y values until you see the first one that goes over 1,000. Once you find it, that's when it's going to occur. So it's going to take about 6 minutes for that to occur. Because we always go to the one that we're rounded up to. 18 is kind of similar to the college question from the last quiz. You have to decide between 2 job offers. Judison Industries has offered you $30,000 with an $800 annual raise. Warren Corporation offered $25,000 with a 4%. They give you the 2 equations. So, best option, get them put into the calculator. Making sure you're typing in the x's where they belong. Double check, make sure everything's typed in right. Yep, okay. And I pull my chart. Now, so here at the start, Judison, this one, it's in my blue column, is the better price. As I start to scroll down, though, we're going to get to a point that all of a sudden, now the red column is bigger. So there's 2 ways you could answer this. It's going to take, before the second column gets bigger, it takes 12 years. That's our question down here. Which offer is best? Well, it depends. Okay, you kind of have 2 ways you could tackle this. You could say Judison is, I make more for 11 years, and maybe you don't think you're going to be at one place for a job for your whole life. Most people change jobs 4 or 5 times. So if you're like, shoot, give me the money now. Okay, that makes sense. I make more for the first 11 years. But if you would choose Warren, I make more from 12 years on. I mean, most of us are going to work 40 years. So maybe you don't make as much the first 11, but you make a lot more for the last 28 to 30. Okay, I'm in for that. But whatever it is, you've got to have a reason behind it that's mathematically based. You can't just say, well, Judison, because it starts at 30,000. Unless you're like, I'm only going to work a job for 1 year. I'm just going to change jobs 40 times. Whoa. Or I think I'm going to get fired. I'll miss work too much. No, I'm just kidding. Or something like that. But have your reasoning behind it. And our last one. We're going to invest our birthday money. Woo, birthday money. In an account paying 6.5% interest compounded monthly. Use your calculator's function to determine how long it will take for your money to triple. Okay. First issue. When I'm doing my equation, principal. How much money do I have at the start? Make it up. Okay? So let's see. My birthday's this month. I'll make it up. Let's be realistic. This isn't even realistic, but that's okay. We'll do 100. If you want to get a lot more birthday money, you have people that, you know, just throw the cash at you and make it rain. Yeah, it's fine. You can make it more. So 1,000. 1 plus 6.5% is a rate. Again, if that's a struggle for you, just do 6.5 and divide by 100. That'll tell you what the decimal rate is. Over n. N. How many times something happens in a year? Well, this is monthly. So what's my n going to be? 12. So that goes here. And notice it also goes up in my exponent. But I don't have a time yet. That's what I'm trying to figure out. And the one other bit of information I get from the problem is, how long will it take for your money to triple? 3 times as much. So whatever value you used here, you need it to be 3 times as much over here. So if you did 1 million, 3 million, 1,000, 3,000. And what I'm looking for is, when is y bigger than that? So, get my y equals out here. Clear the other ones out. I don't need them anymore. Again, make sure the 12 and the x, don't lose the x. Because otherwise you'll just get a number all the way down. And so when I pull that, I'm going to start scrolling down until that first y value crosses, 300. Once one crosses 300, that's how long. So it would be 17 years for that to occur. You know me well at this point. I'm not a big surprises person. So tomorrow when you come to this quiz, this is what's on it. So if there's places you're still struggling, you need to look at these. Watch this again. Grab an extra review to take with you to try on your own, and then use this or the key that you take a picture of to get the answers, you know, to double check things. I'm not after today. I'm not before tomorrow. I'm in a meeting. So